I'm Dhiraj Murthy from the University of Texas at Austin. I run a lab called the Computational Media Lab, the graphic over there to the right. And I'm going to try to take you through, as I know it's hot, as you fan yourselves, for a little bit about visual social media research. I'm going to also tie it into some textual aspects as well for us to try to understand the linkages and connections between the two. Before I start, just to get a baseline of where everyone is at in terms of their interests, just with a show of hands, who has done any research work on a social media platform at all? Visual, textual, anything? Okay, a couple. And who have done any work on a primarily visual social media platform like YouTube, Instagram, anything else? Okay, so a lot of opportunity for you guys to learn. If everyone shut up their hands, I maybe should sit down and shut up. So I'm glad I'm here. Let me go through and kind of take you through where I'm going to be going. I'm going to present you with a couple of case studies, one of which I think very neatly fits into the forensic aspect that Rui mentioned in our hooks. That's going to be a case study about ISIS. And the second case study is going to be about Hurricane Sandy and Instagram. So there's a couple of key objectives I want to try to bring through. And I'm going to take you through from the absolute basics. So don't worry about it being overly technical, though I'll take you in some technical directions, or kind of hard to comprehend in that way. I'll start at the basics in terms of actual paradigmatic approaches to the research in these areas, and then take you through these specific case studies, and then some of the larger questions that we can unpack. The kind of meta question before I dive into some of these objectives is, increasingly, when we post things online, we do this through visual means. This is not to say text is not put in conjunction. It very much is. But as we see, for example, with fake videos and fake images, the persuasive power of images and video on social media platforms is immense. We saw this, for example, in the presidential election of Donald Trump, where there were a lot of fake things that helped him, even though he went through and said fake this, fake news, fake everything, tried to claim the Access Hollywood tape was fake even. But the power of these content are actually very powerful. So a couple of objectives I want to try to get through today are, it's really challenging to research visual spaces on social media, though it has a lot of dividends that we can get. So one of the things I want to try to bring through today is, how do we integrate and weigh a lot of the big data methods, for example, that computational linguistics have drawn a lot from and have been able to deal with vast corpora, such as from a bunch of tweets on Twitter, to more in-depth contextualized analysis of social media, where we want to really have a deep dive. And how do we categorize textual and visual content together? Doing so from a point of view that acknowledges ontology and that is very rigorous in terms of coding framework. So how can we break down things into coded methods as we've done with text in the past? So what I'm trying to do in many ways with my research is extend a lot of the methods that have come out from textual analysis and integrate them with visual methods too. And then also, how can we scale the small data to big data? So if we work with small samples, how can we also scale that up if we, for example, wanted to do something like computational linguistic methods or computer vision methods as well? So those are some of the things I'll go through and talk about. So some starting points for you. And some of you will be familiar with some of this literature, others of you will not. Big data methods have been employed successfully in many different areas. So there's actually systematic reviews of Twitter research, and as Rui mentioned, I've done a lot of work in Twitter. 16% of research on Twitter has employed sentiment analysis, right? It's actually, the numbers are even increasing. This is a 2014 paper. And though there's challenges associated with data collection on social media platforms, a lot of work has been done to kind of innovate and make sure that we're doing well in terms of that. Now here's the interesting challenge. Closed coding systems, where we actually go through and say, these are the codes we're going to apply to categorize material, are often very successful, but the problem is they're closed. So when we deal with things that we may not understand, especially complex videos or images, how do we handle that? So that's something I'll be discussing. And that comes with this last point, that often the stuff we see on social media can be extremely messy, right? It's not easy to comprehend. Even if you think of an emoji, right? The happy face emoji, sure, you could classify that easily in terms of sentiment. But what if you have 4 emoji together? What do you do? Right? You have a certain amount of messiness. So these are kind of some of the starting points. So a lot of my work has tried to think through these issues on larger scale from, first of all, a more philosophical question in terms of research methods. And that has been to go through to classic questions of induction and deduction. Hence, my questions about coding schemes and other things. So we're going into this deeply complex world of visual social media where people put this sort of content. How do we grapple with it? So we have classic methods of deductive analysis in terms of research questions and us trying to frame our research that often have a lot of problems within visual platforms. So we have our theory, our hypothesis, our observation, our confirmation. Traditional Aristotelian, Greek-inspired methods, which obviously have a lot of purchase. Now, an argument I want to make today, in both of my case studies, but particularly in my first one, is for you to be open to a bit more of an inductive approach, the Sherlock Holmes methods, so to speak, where we're going to start because of that messy space, and we may not understand all of the actors involved, the users, or the types of content that may be there. So maybe you see an image macro that's part of a larger meme, right? So this is if you have a picture overlaid with block text. I'm sure you've seen it. I'm sure there's ones that exist in Portuguese that become quite viral. How do we try to comprehend this, right? So an argument I want to make here is for us to do that sort of observation, try to decipher patterns, develop hypotheses that we can test, and then build theory. So we're obviously going the other way around from deductive reasoning. And I want to make an argument that a lot of the inductive methods can give us some very useful insights into visual social media platforms that deductive approaches and very closed systems may actually close off to us. So that's an important starting point for me. So kind of going beyond induction and deduction itself, kind of along the branch of inductive methods, we have sets of other methods, which, again, I'll explain how I've leveraged these in terms of researching visual social media platforms. The first are methods that are called abductive methods, the first point right there. And the quote here I think is good, for finding the best explanations among a set of possible ones. So, for example, in my work, I've had to look at data sets of 20,000 Instagram images, right? Or 30,000, images from something, or 1,500 videos. How do I make sense of trying to connect the dots from that large quantity? It's one thing to look at 1,000 words, but it's another to look at that amount of visual content. So this abductive method of trying to find explanation is a really good way to start building those patterns, to start building hypotheses. Another type of method that's quite useful is one called retroduction, so along this inductive line, and defined of a type of abductive method of asking why, okay? So the primacy here really is that asking why part. And the argument is not to close down in a deductive frame, but to try to open up the conversation of why this content may be propagating, why users may be posting this, why it's circulating in networks. So that kind of asking why. So the retroductive researcher, unlike the inductive researcher, has something to look for in that way. So it's kind of beyond this classic induction of the Sherlock Holmes way to being more lateral, more horizontal in terms of keeping approaches open. Now, the reason I've spent a lot of time trying to detail these things is because I think it fits well into methodologies that we can employ in social media more broadly. I've employed it in Twitter, for example, as well as in YouTube, as well as in Instagram. So let me take you through this, and I know it's kind of hard to see some of the fine print there, but I'll talk you through this method, which I've written about in a paper called The Ontology of Tweets, which is a book chapter. And the idea is to take grounded theory, so an inductive approach, and employ that within trying to code things like tweets. And the idea is to have a very iterative process. So iterative here meaning to do it over and over and over and over until we finally get to when we have concepts. So the idea is you start out right here with collecting data, right? In this case, I have tweets, JSON data that's coming the way Twitter delivers its tweet data, and then going through here and actually going through iterations where I'm trying to develop concepts that are emerging from looking through a sample of tweets. So the first thing I want to introduce you to is not even to do with visual, but comes from my textual work. Let's say you have a corpora of 1 million tweets, and you take a sample of 2,000 or 3,000 tweets that you're going to analyze. A method like this can be very useful, where looking through 100,000 tweets is not going to be very possible, or it's possible, but it'll take you a good chunk of your life to do. Whereas if you took the sample and you tried to do a constant comparison where you're deriving various concepts, and then employing methods such as what's called axial coding when you forward a type of code that you're going to apply. So you say, I think this tweet could be this idea, or this idea, or this idea, or this idea. The idea here is you put the tweet in the center with a concept that you yourself think may fit it, and then you put other conceptual ideas around it, right? And you see if those fit. And you keep doing that in this iterative stage and going through maybe collecting more data or doing new samples, and then going to the final points of actually refining, coming up with core categories, theories, and then being able to evaluate. So this idea comes from my work in textual and linguistic-oriented analysis of large text corpora. And what I'm going to talk to you today is how you can take strategies like this and extend them into visual areas and integrate them with visual content. And if you have any questions about this once I finish the talk, I'll be happy to take them. So I'll give you the case study of ISIS, which, speaking with Rui and understanding some of the work done on the forensic side, I'm hoping this will be of interest to the audience, whether or not you're interested in the forensic side. The first is I use methods that are called fuzzy methods, and the term fuzzy comes from computer science. So the idea that we don't quite have that 100% ironclad closed category system of understanding the data, but we have a fuzzy way of understanding things. And this is a case study that deals with YouTube, which is, I think, a very under-researched platform, but a great case study to talk about. Because in the case of ISIS, it's been very well documented by journalists who interview jihadis that YouTube was very instrumental to convincing them to actually believe in the ISIS doctrine. So what I do is I go from large-scale data mining to small-scale human coding that follows the table you saw on the previous slide, to generalizable characteristics, and then talk about potential applications to big data methods. So there's a lot that I'm trying to do in this case study, and it was a 2-year project that involved watching a lot of ISIS content, which I don't recommend. Okay, so let me take you through what I do in this case study. So first of all, I looked at the sort of content that was going on in other networks. Okay, so I didn't start with just looking at YouTube. But one of the things about visual social media is they connect, they intersect, right? Someone posts something on Facebook, it maybe goes to Instagram where someone takes a screenshot, then someone does a mix of things and then sticks it on YouTube, right? The platforms are interconnected. So I spent time looking on Twitter of what ISIS was doing, Facebook, Instagram, and YouTube. So the first point I want to make here is when you are researching anything on social media, even if it's Twitter, is to take the time to try to broaden your search across platforms, because I'm finding increasingly the platforms do have some connections and things jump from platform to platform. So you can see here, for example, an image that was posted on Instagram with a couple of hashtags here. And it turns out, actually, ISIS encouraged people to bake things like cakes, pastries, other things, with ISIS flags and ISIS branding, because people are interested in things like baking and cooking. And it actually was connecting to women and other populations that weren't traditionally connected with through, for example, hardcore gaming motifs that were coming out of ISIS. By going through and doing some of this, it also helped me understand the diversity of content that actually ISIS was engaged with, which was pretty fascinating. And also the integration of hashtags, which are textual, and how these things were connected, right? And the type of users and their networks. And I used network analytic methods to map out some of this. So then I started thinking about this and looking more at the images, and most of these are coming from YouTube stills in terms of what they were doing. So obviously, ISIS uses social media as a key part of its recruiting strategy. And I put this quote, which I think is a really compelling one. A Western ISIS defector named Ibrahim states in an interview, a lot of people, when they come, they have a lot of enthusiasm about what they've seen online or what they've seen on YouTube, right? Simply put, this is a platform that enables, in the case of ISIS, this, but lots of organizations to get messages out. In the case of the US presidential election, it was the alt-right that was able to communicate very effectively on YouTube. We see now in Europe, a lot of the nationalist movements are using YouTube as an organizing platform in similar ways to communicate. So some core research questions that I'm trying to look at are kind of beyond this talk to explain, but a key one is, given that Islamic State content is regularly deleted, but also reposted, is there a way for us to think what's happening in terms of how YouTube is directing people to this sort of content? My hypothesis here was that not everyone is already going to be radicalized. People are going to go to the platform, be recommended content, and then eventually fall in the rabbit hole. But from the point of view of a researcher, are there linguistic or other markers present from the video content, whether that's in the title, whether that's in the description, whether that's actually kind of metadata attributes that I can use for classification, okay? So an important part to focus on here is, even though this is about visual social media, one of the methods I'm going to present to you is actually coming from the linguistic textual frame, because it's one that we can mine and scale up as well. But I will talk about how you actually do have to look at the video content too. You don't have to, but it does help. So let me talk to you about some of the case study methods I used here, which I think is kind of interesting and presents an opportunity to look at a lot of cases, not just on YouTube, but a lot of other areas. Because ISIS is kind of hard to understand in terms of what they're doing of recruitment, it's not similar to, say, a company launching a marketing campaign like Coca-Cola or something. It's hard to actually find jihadis who have been through the program of YouTube radicalization. So I had to look at news articles that actually talked about what videos seemed to be compelling and which ones were authentic. And then what I did is compile the list of those videos that journalists said were authentic and were persuasive, and then searched on YouTube for these videos. And I used them as seeds. And the idea was I would crawl the YouTube network, and YouTube, for those of you who don't know, has a relatively open API, so it's fairly easy to access, and then crawled YouTube to get a list of all these videos that were recommended by the seeds. So to basically go to those videos, see what videos were being recommended, and then seeing what the recommended videos were also recommending, what's called 2 degrees in terms of the network. And I use a method, which I'll introduce to you as well, called qualitative comparative analysis, QCA. And I use this to build a framework of the recommending videos. And QCA is a qualitative method. So I'll describe both the crawl method as well as QCA in this first case study. So what I did is actually made this list, and you can see here, again, very small, but a list of the video IDs, which are from YouTube, all of them probably deleted now. The actual titles, like Mujah Tweets, Islamic Caliphate, Mujah Tweets, Raqqa Market, ISIS Video, Flames of War Trailer, Deterring the Hirelings, etc. I saw if I could find these videos that the journalists recommended, and if I could, went through and classified them as seeds, and if I couldn't, didn't. And that's how I ended up with the 11 video number. And then what I did, as I recommended as I described in terms of crawl method, is went through and got 15,021 videos that were part of this network, with 190,087 connections between the videos, called edges, right? And those were directional. So I was seeing what videos were recommending what videos. Now, to put this in context, I'm assuming all of you have probably been to YouTube at some point or another. Maybe that's a bad assumption, but I'll assume you guys know what YouTube is and have been there or at least heard of it. YouTube famously became even more popular due to what's called its binge watching mechanism that Netflix has and a lot of other platforms, where you go on, you start, and if you just sit on the sofa with your can of beer or whatever else, and you kind of go into your zone, it will keep giving you content that it thinks is useful to you. I'm going to play this video next in 3 seconds. I'm going to play this video next in 3 seconds. So various work has been done on YouTube and other visual platforms that shows once you get sucked in, you have a very high likelihood of staying in, right? In fact, the recommender system accounts for a pretty large percentage of video consumption. So if you search for wanting to learn about doing the dance, the floss, then it will recommend other videos that are similar to that, and maybe you eventually become a master at doing the floss. I will not even try it. But it will take you in. I have searched for it, and it does do that. And any of these things, because it's a recommender system, is designed to do that. So that's basically where this is coming from. I wanted to study this because I can't, well, I could, but it would be a very different and difficult research process. See how, if you weren't radicalized and you went to YouTube and you started looking at things, how it might look from your vantage point of going through the YouTube network. So I collected this data in October 2016 using YouTube data tools, which if you search online for it, you'll find. And I used a tool called Gephi, which is a very popular network visualization platform, to visualize the network and observe what videos were recommending each other. So this is just dealing with the videos as abstract data entities, not actually looking at each individual video, though I do some of that coming up. So coming from this, the idea is, as I kind of poked at before, to probe YouTube's recommender algorithms as well as its search algorithms, and trying to understand how the black box was working in terms of YouTube. So I find a very fascinating area of social media research itself is to try to understand how the algorithms of social media are working. This is the whole thing of, if you go on Twitter, what tweets are recommended to you, what users are recommended to follow. Same with Facebook, what comes up in your feed, who's recommended. As we know from the Cambridge Analytica scandal with Facebook, the role that algorithms play are pretty darn powerful in terms of our experience of the social. People argue it can swing elections, it can cause riots, it can do all sorts of things. So if that's the case, then trying to understand the algorithmic influence is also pretty important. So we can only try to reverse engineer a lot of stuff that's happening on social media. And you guys may not have an interest in some of the algorithmic questions. You may be more interested in the content analysis part, and some of the methods I'll talk about reflect on that as well. I'm just describing this at a large scale to explain kind of the scaffolding here. So one of the problems with a lot of social media platforms, even Twitter, where we have relatively open access, is we will never have all the data, right? Even governments don't have all the data, unless maybe you're China. But it's just the companies that have that data. And even they don't have all the data because they don't have other competing social media platforms' data. So the closest you're going to get is if you sat behind the screen at Facebook or Google or somewhere else, but even then you may have a partiality. So what the research is premised on is that we don't know what percentage of users are actually being exposed. We don't have any of that information explicitly in terms of who's gone there on accident or purpose, because I'm not actually collecting the data from Google's point of view. I'm doing it from this network mining point of view. So what are some results that I can decipher from this? And I'm just going to present to you some very accessible elements of the research to also whet your mind in terms of the possibilities, and then facilitate you asking questions about some of this. Some of it comes from actually going through, and like I said, with that table, remember with the iterations, where I said to keep looking at things and keep trying to conceptualize. I spent a lot of time before undertaking the actual mining going to YouTube and trying to see what was happening, right? Using VPNs, using Tor browsers, other things that would basically erase any kind of identity so I could experience things, I would search for things, right? And I would actually see the radical videos being recommended. And if you enable the little blue thing over there as the autoplay, so eventually you'll get to this content. Sometimes it appears in number 1, 2, 3. Sometimes it appears in this case, 1, 2, 3, 4, 5, 6. About number 8 is the first ISIS video that comes up. But like I said, sometimes people will watch quite a bit once they go to one and they find it interesting. YouTube and other things like Amazon are pretty good at recommending what to watch. So how can we combine this sort of small data that I found impressionistically with then the bigger scale that I've done in terms of the mining? So I want to talk about a little of that. First of all, from the network part, and I did mention part of this was done from a network's point of view, we can really focus in on what's happening. So any of you with network analytic methods, researching this sort of platforms using a network-based perspective can be quite good. So I look at one video right here, the No Respite video, which is a pretty gruesome video in lots of ways, also became very popular. And the black nodes here, so such as these, represent official videos from ISIS's media wing at the time, Al-Hayat, and blue nodes do not. And the idea here is that you can actually see how videos come in, and then how non-radical videos that maybe have a similar title, which I'll get to later, actually recommend the radical video, right? So we can go through. And then another thing, one of the interesting things of actually using Google's tools to study Google is you can do things like Google Translate. So I was able to take a large quantity of these videos, which were actually in Arabic, that we're recommending, and translate their titles. So I'm able to take everything to English. In the case of here, you could translate everything to Portuguese from Arabic and English and then have that, or whichever way you want. So it opens up from a textual reading of the titles in the network graph new possibilities for research that go beyond one's native language, which I think is pretty important from being able to answer questions here. So kind of going through to this is only partial, plus it's a huge network. So I have to focus in and look at particular aspects of the network and then use those as kind of micro case studies. I wanted to do something that was more systematic, that tried to then understand why videos were recommending other videos, right? A key question for governments too, of how are these people actually coming across things, whereas if you went to YouTube and you searched for radical things, which you may not want to do because you may not be able to fly if you do that lots of times because the government will be watching you, but most people don't know what to search for, right? So they've gone in this rabbit hole, perhaps accidentally. But I want to find out, are there linguistic, cultural, or other attributes that are causing this? Why? Because I'm hypothesizing that Google does not want to spend immense quantities of processing power mining videos, right? Because if you took something like computer vision and looked through the videos and tried to study them to make recommendations, that's really expensive from a processing power point of view. It also fits in with why, especially European governments are saying now, why is there all this radical content? Or the case of the German government, YouTube, why do you have all this Nazi content on? Well, they're not actually diving into the videos. They're just looking at the surface and trying to extract what the video has in meaning. So based on this, my assumption was that the recommender system is probably working on textual, working on linguistic stuff. So I used qualitative comparative analysis, which is called QCA. For those of you who are interested, the prime person behind this is someone called Charles Regan, R-A-G-I-N. And there's a lot of literature, and the software that's used to study this is also described quite well. So I used QCA to try to look at samples of the content that were recommending ISIS videos and content that did not. And what I did is actually took random videos from YouTube as well. So I used random video generators. And I used radical videos, and then I used videos that weren't radical. So I had 3 types of videos in my larger sample. And I coded these for 11 attributes. So I went through and took 11 attributes, looked at this video sample, and then did the coding for that to try to do some understanding of what may be happening in terms of videos. okay? And I can describe that in more detail afterwards. So what QCA does is spit out is not the correct thing, it generates possible explanations. And this is done iteratively. And you, as a researcher, qualitatively have to look through to see if that makes sense. So it gives you what kind of comes from the notion of John Stuart Mill and recipes of things of causation. Okay, so the idea here is not necessarily having direct causation, but possible attributes and explanations that would help us understand why things are happening. Okay, so this isn't a one-click process. So software FSQCA, the FS stands for fuzzy set, really needs a human in the loop. So you go through and you evaluate these explanations to see if they hold water. So I went through and did that. Went through lots of these iterations to see. And the idea here, the high stakes thing in my mind was if I could figure out what was happening in terms of why YouTube was making these recommendations, it would be a pretty big deal, at least from my point of view. And then what I found out is actually we do have something that comes out. So the output goes through and it says the thing that influences the process the most is actually having a keyword in a YouTube video that matches the radical video, which is pretty shocking to me. So 34% of the recommendations, 34.69% of the recommendations are just because the video has a similar word. So if you remember to the one that had no respite, other videos that had no respite, like no respite from the floods, no respite from the hurricane, no respite from something else, were recommending radical ISIS videos, even though they had nothing to do, just because they had that term no respite, which was pretty shocking to me because this is YouTube, and you would think that it was doing something far more complex, but it was looking at the title and looking at other videos with similar titles to get there. Then you have some smaller amounts of percentages explained. The larger one is 28.57%. If the video was a newscast, if the video was posted by an organization, if the video was in English, and the video is recent. So those are Boolean terms. It has to be and. All those things together. So if a video has those four attributes, 28.57% of the recommendations could be explained by that. And then you have smaller percentages here, which include some knots. But the idea here is I could go through and explain 69.39% of the videos that were being recommended through these textual attributes, basically, that were coming out largely, but then some others like organization, but linguistic in terms of language, and temporal in terms of whether a video was recent or not. So for me, this was a really big deal to go from something which, if you look at the face of it, lots of these videos that would be really hard to study. If you could break it down through these iterative methods, you could get to some, what I think are some pretty interesting conclusions that emerge at the end. So why my approach? First of all, I mean, it is a lot of work, as you can see, but I think the payoffs are pretty big. You can study these really interesting things on large-scale platforms, start with the small aspects, like I'm doing with the samples, then be able to generalize using things like QCA to larger things and answer pretty big questions. I think there's also one of the things that has stunted a lot of this type of research in the literature is there's really not that many accessible examples of this sort of mixed methods thing. On the one hand, you have purely computational approaches that go through and will mine metadata or something else and try to scale that. And on the other hand, you have a qualitative study of maybe one ISIS video, or I'm not even talking in the case of ISIS, but a qualitative reading of a couple of videos. So you have this huge gulf in between, and I think that's a really important area that all of us in the room can potentially tap into. So we either tend to have this big data or small data, and the two don't synergistically operate. And I'm a big believer that small data methods are really powerful and that can potentially scale up. And scale up in really, really big ways. So one of the ways I've been working with, and this is currently what I'm doing with this project, is if I were to take video and images together, so I'm going beyond just that video network and putting video and images together, and I take random samples, I take these radical extreme samples, I take human coding, what if I then brought in machine learning? So I take this and use it to provide supervised data to actually have deep learning or machine learning methods so that I could go through even larger sets of data using those attributes. So if I told the computer, look, 70% of explanation can come out with radical keyword, can come out with newscast, organization, English and recent, I could train a computer algorithm to try to pick out more videos. Not to say 100% this is the case of what's happening, but to pick them out, and then us as human researchers could go through and see if that's happening. This could scale up in a very large way, right? That started with those small sets, came out with generalizable attributes, and then could go back to a computer to scale that up. Not to say you have to do that, but that's now something I'm approaching in terms of the next phase. So let me take you to my next project, which is quite a bit different. Has nothing to do with crime, has to do with disasters, but does have to do with another popular social media platform, Instagram. So I'm going to take you to case study 2, Instagram and disasters. So this is some of this is published as a paper, and I provide the reference to this during the talk. So it's hard to read this, so I'm not going to read it out, but I'll tell you what I'm trying to do here is anytime there's a disaster, whether there's an earthquake, whether there's a hurricane, whether there's a flood, it's a man-made disaster like a nuclear power plant has damage. People go on social media, whether that's Twitter, whether that's Facebook, whether it's Instagram. Even people post YouTube videos in the moment, right, and post that. The argument I found, and I've done a lot of work on disasters, is this is another really important area where we've done a tremendous amount of work in crisis informatics in terms of looking at Twitter and people posting during Twitter. We have not done that much work in terms of Instagram, YouTube, and other visual platforms because, again, it's hard to study. But if someone posts an image or a video of their disaster experience, it says a lot. So I'm currently involved in a project of looking at that in the context of Hurricane Harvey. So this kind of continues that line of work. So what I try to do in terms of this is make an argument that visual data is often perishable. Now I know this smacks against some of the logic that if you post something online, it's always there. True, but is someone going to find it? Okay, so there's a temporal argument I'm making here that one of the challenging things to do in a lot of this research is also to get the data quickly after an event happens. And that's a really challenging one, right? But I think it's really important. So in the case of a disaster, I often have to already be collecting the data or be collecting it literally right when the disaster happens, but often beforehand, which means part of the argument I'm trying to make here of social media is being proactive in terms of trying to research things. That means already having relationships with centers or labs or institutes that are collecting this sort of data, so you may not have to do it yourself. And in my lab, that's what we do with a couple of streams. So then in terms of Instagram, there was a time when it was linked with Twitter. It no longer is. And I had the opportunity to be able to harvest Instagram images from Twitter data. So it's a method that's harder to do now, though it can be done with Instagram in different ways today as well. So what I tried to do is try to create a documentation of what was happening in terms of Hurricane Sandy before, during, and after, and try to understand the visual representation of a lot of what was coming out of this. Because many traditional forms of social media data harvesting are not prioritizing social media data. They're prioritizing text. They're prioritizing things that you can get out. The most visual often they get is emoji. And oftentimes they deal with a very facile analysis where they're trying to do positive, negative, or neutral sentiment classification, which if you look at how especially younger people are using emoji, they use them often in ways that are not smiley face, sad face, neutral face, but actually different things. So how do you actually extract meaning from that? So by just doing JSON extraction of tweets, we may not have everything there. So what I did was actually extract the URLs with images too, and then went through a laborious process of trying to study these things. But again, I want to make the case that this had pretty big payoffs from my point of view. So when you have these big data flows, it's hard if you don't actually have good selection criteria to narrow down things. Otherwise, you're going to get this huge stream of data coming your way. That's true in text. and true in image. Now, the thing with text is if you have lots of text that comes down the pipe, it can be easier to deal with in terms of topic modeling, in terms of frequency analysis of particular words. But for images, that's really tough, right? Even if you run that through computer vision, it's still a tough thing to do. Another thing is there's a lot more API restrictions, application programming interface restrictions. So you go to Facebook, you go to Instagram, and you say, I would like this image, right? Most of them are closing down access to their platforms in terms of trying to collect this data, right? It's progressively, and I think post-Cambridge Analytica, this will be done more in the guise of privacy, where companies, even though it's not a privacy issue per se, it can be, will want to deny researchers this sort of data, saying that it violates privacy. But I think it's a pretty important area for us to be researching, or we have no idea what's happening in terms of these systems, and they remain black boxed. So there's no real priority placed on the visual, but I think there should be. Or at least there should be placed a priority of the visual and the textual together to provide a full understanding. The argument here is a larger theoretical argument I'm making, that if we just are looking at things from a textual basis, we may not actually be getting the correct textual understanding out, if that makes sense. So I'm saying if one is interested even in the linguistic attributes of the stuff that's coming through social media, having the visual attributes together will probably provide you with a more robust or rigorous linguistic understanding of what's happening on social media. So I know kind of a weird argument, but I think it's an important one to make. At least that's a perspective I'm taking. So you've got Instagram, Facebook, Twitter, all these things in the constellation. How can we deal with this? So one approach is to take machine-driven methods to try to deal with this. So you take machine learning and AI, such as topic modeling systems, and LDA has been used quite a bit to derive topic models. And you can do this with images. So what you do is you run it through something like Google Cloud Vision. I don't know how many of you have used tools like that, but there's Google Cloud Vision. There's also an Amazon Vision. And then you can extract the features from images. So basically, you could pass 10,000 images to one of these platforms, and they'll return back features saying cake, chair, camera, trees, person, anything else. And then you could topic model that. However, this is at the basic level. So if you were to take that and try to mine images or stills from videos, you're dealing with things at a pretty basic level. So what I wanted to do is go a little deeper, not hugely deeper, but a little bit deeper in terms of trying to understand what people were posting during a disaster. So even though it's tough to decipher individuals and the type of things happening here, I think there's a lot that that can be done here. Because machine learning finds this stuff really challenging, having humans in the loop gives us a lot of opportunities. So rather than running straight to the problem and trying to solve it with qualitative or even mixed methods, an argument I want to make and that I employed in this was that we can use some what are called hard methods here. These data are going to be hard to understand, but there's a lot of value, and there's good methods to try to be able to understand them. So first of all, having humans in the loop, not just having the robot do the things behind the scenes in terms of an algorithm, have huge payoffs. So even though algorithms can parse through this stuff at the big data level, having humans in the loop to try to read through some of the content to look at the images, I think has a lot of purchase. So what I do in this project is I start with something that I call motif level analysis. So I'm trying to understand the genres or the main category of what the images are trying to convey posted during Sandy. So I code, we coded these for a particular theme or category. The thing is a lot of efforts involved. You can change that by crowdsourcing it, using something like Amazon Mechanical Turk or having a large team. These are possibilities if you don't want to have all the weight on your shoulders. You do need at least 2 coders trained so that you can do reliability checks between 2. So if you're dealing with 20,000 images or 30,000 images or 40,000 images, it can be pretty tricky. So figuring out how many images you're going to study to be representative of your question is a really important one at the beginning. So that when you go in and you recruit coders, whether you're putting them on crowdsourced platforms or you're doing them yourself, you're organized in that way. and really checking intercoder reliability from the beginning. So kind of going through my mistakes in the past and passing those on. Early on in my work in this, I kind of ran through and didn't stop to do samples and check as much, and I paid the price because I'd have to go through and redo it. So starting out early and taking samples and running checking between 2 coders or 3 coders or 4 coders or 5 coders to make sure people are interpreting images is really important. In fact, we find this with text itself. I've done a project where we were studying tweets about Donald Trump, and it turns out humans have a really tough time interpreting content about Donald Trump, whether he posted or other people post about him. It's hard for us to decipher that sort of discourse because it's pretty polarizing. People are really, really emotional, and it's harder for us as humans to figure out where that sits on a spectrum. Same thing with images during a disaster, right? This is pretty emotional stuff if you see a building that's been destroyed and people bleeding or something else. How do you classify that? So it's really important to invest a lot of energy in the beginning of actually testing the agreement between people on coding image content just as it is in difficult text content. So the case study in terms of this is that we were looking at these Instagram images posted on Twitter during Sandy, harvested them, and now Instagram doesn't allow you to scrape. So there are other methods you can use. A lot of research that's done now in visual platforms where you can't actually collect the data directly from the platform involves doing things like taking screenshots and other things. So there's an additional layer now of how do we actually get the data. Or what laws you may be willing to break. On my side, I don't do any of that, so I've got to follow all the terms of service, which means it's really hard to do a lot of the visual work. Not as much on Twitter, but again, it depends what value you think Twitter is versus Instagram versus Facebook, and the big one in the US, Snapchat, which again, you're going to have to either get some screenshots or something else to study these sort of platforms. So in our case, we studied Instagram during Hurricane Sandy with a 2-week timeline and 11,964 images that were studied. 11,964. We went through and double-coded each of these. And we did iterative sampling through the whole way. It took a long time to do this project. The paper only came out last year, and Sandy was a while ago. So it's not a quick process by any means. So you get images like this, like I said, which are hard to figure out. You see the destruction, you see the people, how do we interpret them? So coming from these 142,768 tweets that were geotagged with Sandy Hurricane Storm from 2012, got these 11,964 images, and then eventually, after the iterative grounded theory coding schemes, we came up with motifs like food, relief, people. Easy to understand things, but computer vision would not have deciphered those things in the first instance. However, as you can probably tell, I could pass these to computer vision after coming up with that coding ontology, and I could scale even larger. The argument I'm making here is first we've got to invest the effort to actually come up with the categories if we wanted to scale to machines to actually do this. So images that fit multiple codes were double coded. So I actually had 15,985 coded instances that came out of the 11,964 images. And we see stuff like this. Okay? And one of the cool things about this is because I didn't have a deductive frame where I went through and said, this is what I'm testing for, it was coming up inductively or more, abductively. I kept myself open. I had no idea, for example, food was going to be so huge. It turns out in a lot of disasters that are forecasted, in the case of a hurricane, you get a bit of advance warning. People tend to go through a stage where they're kind of in denial. They don't know what's going to happen. They don't know how much their life is going to be affected. In the case of New York, affluent population, one of the most richest cities in the world, people went out and partied, right? So you see people drinking before Sandy made landfall, having huge parties with food, and that was a really big deal. And then also image macros. So these sort of things that became memes. What if Gangnam Style is a giant rain dance? And funny things, which were used by people to cope with the disaster. I saw this during Harvey as well, that things happen. And you kind of are able to map these in terms of cycles too. You can see then people shopping beforehand to get supplies. You can see what happens when New York gets flooded, the damage, the people who are involved. You see people taking their pets for walks after a little bit of the debris is cleared. And then you see people taking screenshots of their text alerts. And alarmingly, you see very weird ads that came through, this one by a company called American Apparel, which is really troubled. In case you're bored during the storm, 20% off everything for the next 36 hours, which was deeply troubling. Again, things I wouldn't have found if I went through just asking classifier and machine learning to find stuff. So by going through and taking the sample and looking through at the broader scheme, I was able to tease out some of these larger things and then be able to answer what I found were very interesting questions in terms of Instagram and image circulation. So I found some interesting flashpoints that came out of this project. There's copyright and ethics issues. Some of these images have copyright things, and we're seeing larger and larger questions in terms of that. Computational skills. Research projects like this, I find when I talk to people, requires a lot of technical ability. So there's a kind of needing to scale up literacy in terms of how do you go through, how do you do the mining from platforms, from APIs. So if you're interested in this sort of stuff, I encourage you to seek out the resources to learn some of these computational skills. Data access issues. Some of the APIs are being closed down, so the data may not be easy to get to. But again, there's methods to get these data. So if you're interested, think and research and learn more about how to do that. Data costs, that's a big thing. Now that platforms are closing, they're trying to sell data. And I'm finding even some of my doctoral students have to pay for some of their data. That's a really tough challenge, especially for students, but even faculty or more established researchers. And that's going to really affect this type of research. And time limitations. If a project like this takes a couple of years to do research and come to fruition, is it necessarily worthwhile? Of course, I'm going to make an argument it is, but that's something to take into consideration. I think it's definitely a flashpoint. It's definitely an issue. Now, something that comes through in terms of some of the conclusions from this project for me is I think there's a real crisis, funnily enough in this case, of crisis data, right? Because we're not often able to meaningfully engage with the large quantities of data that are produced by people during events, whether it's crisis or whether it's an everyday event or whether it's a more profound event like an election. So researchers tend to feel the pinch in terms of all this data. The expectation as we go, and a lot of governments are trying to put a priority now in terms of agendas for researchers to collect more and more data because our computational power is getting larger with supercomputing. But we, as humans, it's hard methodologically to deal with that increasing data. So some of the methods I've tried to frame here today try to to leverage advanced computing methods, but also harness small methods as well. So many in my field in communication research feel overwhelmed with trying to do these terms of research projects. And one of the reasons why I wanted to introduce these two case studies to you is to say you don't have to have all the training to do elements of this. For example, you could take some images and do a small project on them. The idea is to open up and show you the diversity of options you can do in terms of research. And oftentimes I find the disciplines in humanities and social sciences lack a lot of this technical literacy. So how can we do this? So silver lining is, I think a lot of the mixed methods approaches I've talked about, something like QCA, for example, we have skill sets that we can do that. So I think that's a silver lining. And one of the big things I find when I do this sort of research is we have a lot of expertise coming from all our different interdisciplinary backgrounds that someone in computer science may not have, that may be looking at it from a purely computational approach where we may have different things at stake in terms of how we're approaching it. So I hope this talk has been of value, taking you through two very distinct case studies, but emphasizing the visual nature, but also tying into some of the metadata and textual attributes that we can harness from. And if you're interested, please do reach out to me and feel free to, as Rui mentioned, I wrote a book on Twitter. Shameless self-plug, the second edition has just come out. It's newly updated. It covers Donald Trump and everything else that's weird with Twitter. So if you're interested in Twitter as a platform, there you go. Thank you very much for having me. I'd be happy to take any questions.